Hi everyone, welcome back to the new video of the series Simplifying Tech. In this series, we aim to make the technical concept easier for everyone for understanding. So whether you have some experiences in the technical domain or you are completely new but you have interest and enthusiasm in learning the technical concepts, this series is simply made for making tech interesting and easy for understanding for everyone. In this video, we are going to understand about the booting process of a computer. So what are the sequence of steps which happens once you press the power on button till the operating system is loaded into the RAM for execution by the processor. So we are going to understand the sequence of steps which follows once you press the power on button till the operating system is loaded into your system. So let's understand it step by step. I'm going to use this drawing board for explaining you the things. So this is a non-coding video. I understand for the technical people it's going to be a bit boring, but I will try to keep the video as simple as it is and interesting as well. So let's move down and let's understand the sequence of steps which happens once you press the power on button. So once you press the power on button, so the power on button sends an electrical impulse to your motherboard. So let's write motherboard over here. Okay. Now motherboard is also another electrical component. So what will happen is that it sends a message which is popularly known as the power OK message to a special chip which is present on your system, which is called the ROM BIOS. So ROM BIOS is present by default on every motherboard or every system, you can say, and it is provided by the manufacturer, which consists of two important things which we will analyze just now. So ROM BIOS stands for the read-only memory basic input operating system. It is a chip which is embedded by default in the motherboard by the manufacturers, and we cannot edit any configuration of the ROM BIOS because the name itself says that it is read-only memory. It is intended for reading only and we cannot write any data to it. So the motherboard will send a power OK signal to the ROM BIOS, and the ROM BIOS now performs two things. One is the post and other one is the searching for the boot sector in the secondary storage devices. So let's make a box over here to indicate the functionality. So the first functionality which the ROM BIOS performs is the post, and the another thing, just a minute, and the another thing which it performs is it will search for the boot sector. Now what is boot sector? We'll understand it just now. So let's make a gap between them so that it looks tidy. Right. So what is actually the post test which is done by the ROM BIOS? Now post stands for power on self test. Now it is actually a hardware test which is performed by the ROM BIOS to check whether all the electrical components inside the motherboard or the CPU is getting electricity properly or not, whether the voltage being present in both the CPU, the hard disk and the other devices of the motherboard is coming properly or not from the SMPS or the switch mode, power supply or the battery in case of laptop. So the post test is performed by the ROM BIOS to check whether all the hardware present inside the motherboard or all the electrical components present inside the motherboard is receiving power properly or not. So this is the post test, which stands for power on self test. Now once the post test is successful, many computers of old generation, they give a beep sound which indicates that yes, the post test is successful. If the beep sound continues for a long time, beep like this, then it indicates that some sort of dysfunctionality is there being present. For example, the RAM is not receiving power properly, maybe the computer fan is not running properly, maybe the other components of the hard disk drive is not receiving the power properly. So various beep sounds indicate various default means options available or the various malfunctionalities which are happening on your motherboard. right? So after the successful post test or the power on self test is performed, the ROM BIOS starts searching for the boot sector. Now what is the boot sector? Now the boot sector is actually the place which consists of the configuration for the operating system. Now the boot sector is actually present in the hard disk drive, and we know that hard disks consist of various disks like this, right? Suppose let's move out of scope for the time being. So let me explain you how the hard disk actually functions. So this is suppose a hard disk. Now hard disk consists of various disks, or you can say sectors, one disk only, and inside the disk there are various sectors. So you can call it as labs as well. So okay, just a minute. Yeah, so this is actually a hard disk, the disk present inside the hard disk, and there are various, you can say, tracks present inside the hard disk. So if I divide the hard disk in this way, you probably are going to understand in a very clear way what is the difference between the sector and a track. Okay, now if I zoom into this picture, this is actually how a disk looks like. Now inside this disk, this part, as you can understand, I am trying to draw with a pencil. If I change the color to something else, so this part is actually called the sector, and this entire thing is called a track. This last line is called the track, and this portion is called the sector. So why did we come from the booting process to this boot sector? So boot sector is actually a place which consists of the configuration for the operating system, and the major function of the ROM BIOS is to first perform the post test, and next is to search for the boot sector. Now where is the boot sector present? The boot sector is present in the 0th track, first sector of the hard disk. Generally, if it's a pen drive, then it's some other configuration, but in case of hard disk, which most of the system use nowadays, the operating system configuration or the boot sector is mainly present in the 0th track, first sector. So 0th track means this one, and first sector probably means this one, that depends. Okay, so 0th track first sector consists of the boot sector. Now what does this boot sector actually consists of? Now this boot sector is actually consisting of 512 bytes. Now what is present in this 512 bytes? We will understand it one by one. Okay, so let's connect it. I have no reason why this box color is coming yellow. Okay, I solved it. So search for boot sector. So the boot sector is generally of 512 bytes. Okay, now out of this 512 bytes, 510 bytes is actually the master boot record, and the other 2 bytes is actually the magic number bytes. Now what is the magic number bytes? We are going to understand it shortly. So out of this 512 bytes, the first 510 bytes consists of the master boot record. 510 bytes consist of the MBR or the master boot record. Okay, now master boot record, and here it consists of the magic number. Okay, and it is of 2 bytes, obviously, since the 512 bytes is the boot sector. Okay, sector. Okay, so the 512 bytes of boot sector, out of which 510 byte is the MBR or the master boot record, and the remaining 2 bytes is actually the magic number bytes. What is magic number bytes? We will understand it. Now inside this master boot record, it consists of 2 parts. One is the bootstrap code, and the other one is the information about the partitioning of the hard disk, which is the partition table, as you can see. So what does this 2 things contain? What are the 2 things it contains? One is the bootstrap code. Okay, and the other thing is the partitioning table. Now, what is the significance of partitioning table and bootstrap code? We will understand it. Okay, so let's connect it. Yeah. So as I said that the 512 bytes of boot sector consist of 510 bytes of master boot record or MBR, and the rest is the 2 bytes of magic number. Now the 512 10 bytes of the master boot record consist of two things. One is the bootstrap code and one is the partitioning table. Now what is the significance of this bootstrap code? Now this bootstrap code is a complex code which is important for loading the bootloader inside your RAM. So this bootstrap code actually consists of instruction for running the operating system inside the RAM. So as you already know that some bootloaders are present in your system, for example the Windows bootloader or the grub in case you use the Linux system. So that bootstrap code consists of the bootloader software or the instructions which tells the processor how to actually start the operating system. Okay, so and this bootstrap code is generally of 446 bytes. I'm sorry for the type. Yeah. Okay. Now out of 510 bytes, 446 bytes are occupied by the bootstrap code, which consists of the bootloader which has instruction for starting the operating system inside the processor. Now apart from this, there is the partitioning table which is of 64 bytes. Okay, so the calculation remains constant, proper. Now what does this 64 bytes of the partition table consists? This partitioning table has information about what is the file system of your computer, whether it is NTFS or FAT32. Now what is NTFS, what is FAT32 maybe sounding fancy for the time being, but the people who are from the tech domain will understand what is FAT62 and NTFS file system. So it is a type how the files are actually stored in your computer. So it can be NTFS way, it can be FAT32 way. For the time being you can understand it in this way, but it is a bit different. Okay, now partitioning table also consists of information about how your hard disk is actually partitioned. If you go to this PC of your system, or in case of you are using a Ubuntu system, you can go to your computer. There you can see many hard disk drives are being displayed. So that is nothing but the partitions which is done to your hard disk drive. For example, the C drive, the D drive, the E drive. The information about all these drives, about how much space is occupied by all the drives, how much free space is acquired, or how much free space is present. All these things information are stored in this partitioning table, which is allowing the operating system to get complete information about the system and the hard disk partitions. Okay, so out of this 510 bytes, the 446 byte consists of the bootstrap code, which consists of the bootloader, which has information for starting the operating system, and the remaining 64 byte consists of the partition table, which tells what is the file system architecture of a system, whether it is NTFS or FAT32, and also about how many ways the disk is partitioned, whether it is 2 ways, 3 ways, means how many partitions are present in the hard disk, free space present in this partition, and amount of space which is stored, or amount of data which is already stored in those partitions, right? So this was about the MBR, 510 bytes of the MBR. Now I have mentioned that this 2 bytes out of the 512 bytes, this remaining 2 bytes is the magic number byte. So this magic number byte is actually nothing. It consists of 55 AA. So what is the 55 AA? So 55 A is actually a signature which tells that yes, this is the operating system. This sector is actually the operating system, and this sector consists of the bootloader. So 55 AA is a particularly the signature which signifies to the ROM BIOS that yes, this is the boot sector, Here it is where the operating system is present, and you need to load it into the RAM. Okay, now once the search for boot sector is complete by the ROM BIOS, the next task of the ROM BIOS is to load this boot sector into the RAM. Load into the RAM. The RAM stands for the random access memory. We already know it, right? Or the main memory of your computer. Load the boot sector. Okay. Now once the 512 bytes is found by this ROM BIOS, the next thing is to load the boot sector into the RAM. Now it cannot load the boot sector into any random place of the RAM. There is a specific address of the RAM in which the boot sector is actually loaded. So that specific address is 0x7c00. 0x7c 7c000. So this is a special address where the boot sector is loaded by the ROM BIOS, so that the boot sector becomes available for the CPU for execution. Now once it is there in the RAM, once this boot sector is present in the RAM, the CPU can have access to the operating system, and that's when a computer boots up successfully. That is when the CPU has access to the boot sector present inside the 0x7c00 location of the RAM. So that's how a computer actually boots up. So we will now summarize in detail about what happened just now. I guess I have not complicated the things. We will come from the very start and we will understand how the things are working. Okay, so first what we do is we press the power on button. Follow me very clearly. I will not complicate the thing. So first we press the power on button. Now once we press the power on button, an electrical signal or impulse reaches to the motherboard. Okay, motherboard is also electrical component. So motherboard sends a power OK signal to the ROM BIOS. ROM BIOS is actually a storage device which is embedded inside your motherboard by the manufacturer. We can only read data from it, we cannot change data from it. Okay, so the ROM BIOS now performs two tasks. One is the post and the other one is the search for the boot sector. What is post? Post stands for power on self-test. Power on self-test is actually a hardware test which is done to check whether all the electronic components inside the motherboard's circuit is receiving power properly or not. It may be the computer fan, it may be the hard disk drive, it may be the CPU as well, whether the voltage rating is received properly or not by all these electrical components. Now once the post or the power on self-test is successfully done, the next thing done or performed by the ROM BIOS is to search for the boot sector. Where it will search for the boot sector? In the secondary storage devices, right? Now in the secondary storage devices, if it is the hard disk, the boot sector is generally present in the 0th track, first sector of the hard disks. Right, we have understood what is the difference between sectors and track. So the boot sector is generally present in the 0th track, first sector of the hard disk. Right, now what is the specification of this boot sector? The boot sector is of 512 bytes. Let's move down a bit. Yeah, so the boot sector is of 512 bytes. Out of this 512 bytes, first 510 bytes consists of the MBR or the master boot record of your computer. Clear? And the remaining 2 bytes is the magic number bytes, which consists of 555AA, which is a signature signifying that yes, this is the correct boot sector, this is the where the operating system is present. Okay, now let's come to the MBR. The MBR consists of 510 bytes. Of this 510 bytes, 446 bytes is actually the bootstrap code. This bootstrap code consists of complex code which is responsible for loading the operating system into the RAM, and it consists of the bootloader, mainly the Windows bootloader for Windows systems, or the grub for the Ubuntu systems or the Linux systems, which is essential for starting the operating system. They're a piece of code, right? Now, after the bootstrap code, the remaining 64 bytes are held by the partitioning table. Now, this partitioning table consists of information about how your hard disk is partitioned, whether it has 2 drives, whether it has 2 partitions, or it has 3 partitions. It consists information regarding that. It also holds information about how much free space is available in those partitions and how much space is already taken by data in those partitions. So this information are stored in the partitioning table. Apart from this, how the file systems are actually, whether it is FAT32 or NTFS file system, so this informations are present in the partitioning table of 64 bytes. Now, after the boot sector is found, the next task of the ROM BIOS is to load the boot sector into the RAM. Now, inside the RAM, it cannot store the boot sector in any random location. It is the place whose address is 0x7C00. It is a hexadecimal number. It is an address in the RAM. So in that place, the boot sector has to be loaded. Now the CPU checks whether the 0x7C00 location consists of the boot sector or not. If the boot sector is present, the CPU readily executes the commands present in the bootloader, and that's how the operating system boots up and the operating system starts up in the processor. And with this, we come to end of a booting process of a computer, and this way the computer successfully boots up. So I have tried my best to keep the things simple. If you have not understood, please rewatch this video. I hope you will have a great time in understanding how the computer boots up. So that's all in this video of simplifying tech. I will see you in some other video. Till then, keep learning and keep exploring tech.